second. And down here is just a modem, a dial-up modem. All these connect via the PCI bus. Okay, so we can tell a little bit more by the back. Let's turn the computer on inside and look inside, and we can really tell what's going on inside this computer. Now, if we were to look, let's get a little closer here. We'll look at some of these components in depth. Again, here's the power supply. Now, for various reasons, your power supply will eventually go bad. When it does, it's one of the easier components to replace. Most of them screw out of the back. They connect to the main board like this. This power supply here connects via this connector and this connector. Now that powers the main board and the fans and various components on the main board. In addition, the peripheral components that connect to the main board, the hard drives, the DVD burners, CD-ROM drives, they also need power connections. This is a typical Molex connection, or Molex connector here. And it transfers 5 volts into the CD-DVD burner, this device. Same thing in these hard drives. This particular machine has 3 hard drives. It's a file server. It's got about 1 terabyte of storage on it between 3 different hard drives. So that's pretty much where a lot of my power is going. One of the things that can use a lot of power on a machine, if you're a gamer and you like high-end gaming machines, is the video card. Modern video cards can draw upwards of 100 watts of power. Now, typically on a low-end system, such as one you might buy from Dell, that has been mass-produced and as cheaply as possible, or Gateway, you may have power supplies of 250 watts, 300 watts, 350 watts. So what they have to do is really tweak that to get all of the components in the device to perform with that low amount of wattage. But if you are a high-end gamer, then probably one of the first things you notice is when you buy one of those really fancy high-end video cards, the next thing you have to do to use it is go out and upgrade your power supply. Typically for a good gaming machine, you're going to have power supplies of 500 to 650 watts. Much more power than you would get typically with a mass-produced desktop unit. This is an AGP video card. Let's take a look at some of these components here. Let's see how they fit into the computer. It goes into an AGP slot. Now, AGP is really falling behind as a standard. It used to be a standard for higher-end graphics. Let's talk about a little history here. First, we had ISA, an ISA bus architecture, which was 8-bit, and then we went to a PCI standard architecture, which was, gave us a true 32-bit architecture. And then we have AGP. Let me see. There's a little release lever here. Get this out here. Little release lever, and this AGP graphics card. If you look at the main board, you can see that the PCI slots are a little bit offset from the AGP slots. So AGP is a little bit farther here, closer to the CPU. And when you insert the expansion cards, you can tell whether it's PCI or AGP. These are 2 AGP cards. Now this one's quite a bit more sophisticated than this one, but still, they have that same type of interface in the way that they would insert into the main board. This has a heatsink on it, which covers the GPU, that's the graphical processing unit. That's for carrying heat away from the video card. Has memory chips. This particular card has 128 megabytes of video RAM. So again, if I were going to put this card into or upgrade or alternatively repair this PC, it would go into this slot carefully, and then that slot would clip over it. And then I may lock it down. A lot of newer systems don't even necessarily use screws. They may have some type of a lever that you pull that will lock various components down. Okay, let's look at a PCI card, and we will pull our IEEE Firewire expander card here. and that's PCI. You can see there's a different interface, and PCI just plugs right into the, can you see the white PCI slot there? Plugs right into that PCI slot. And screw there. Okay, let's look at some of the other components that make our machine work. The computer has various parts, but in addition to the power supply, in addition to the expansion cards, which could be AGP or PCI, I don't really have anything ISA to show you. I do have an old ISA mainboard, which we'll look at, but this is an old ISA slot. And those are some of the old expansion cards on older units, these black expansion slots here. Most units today use PCI, AGP, and again, like I said, the new graphics format is PCI Express, which is superseding AGP. Okay, your power supply is very important. Obviously, expandability is important, but nothing on a CPU or computer works without a CPU. And that's what this is. This right here is the central processing unit. It's a wafer of silicon enclosed in ceramic, or actually a multi-layered chunk of silicon enclosed in ceramic, with a heatsink on top of it, thermal paste, and a cooling fan. And that simply cools the CPU, draws air across it. If it didn't cool the CPU, it would basically cook itself, burn itself out. I've seen CPUs with, you know, at least on older models, like a lot of the newer mainboards, they will shut down if the CPU gets too hot to avoid the CPU, harm coming to the CPU. But some of the older mainboards didn't have that feature, that capability, and if you weren't careful and you didn't check your cooling fans every now and then, sometimes one would go out and it would heat up so much it would simply cook the CPU. It would lose the ability to function. You'd have to replace the CPU. Or as is more common today, upgrade the entire computer, because now you can buy a complete computer for $300 and get a deal from Dell or Gateway. But that's the CPU. This is the memory. And these are dual inline memory modules, but these memory slots here, the memory pops out. So I push this out here and I push this out here, these two levers. The memory chip pops out. Notice that I keep my thumb or my hand on the PC chassis. The reason I do that is because electrostatic discharge can build up. Now I'm on a tile floor, so it's not such a problem. Or if you're on an anti-static mat, a rubber mat. But if you were in a carpeted area where the conditions are right, it was cold and dry, you could destroy memory chips and other components in your computer just by the static electric discharge from your body, just by touching the chip. So when you're handling a component, you always want to make sure you ground yourself with one arm to the chassis of the computer, and that'll help you discharge any static electricity and prevent you from harming the components. Alternatively, you can also wear what's called a ground strap. But if you can simply remember to ground yourself out, then you can touch the chassis. To insert it, again, you just want to make sure that you follow the interface. In this case, I'm going to fit this into two slots here and here. This is 168 pin. Yes, this is the older mainboard, those of you who are laughing. And we're good to go there. Now the next component, a lot of older mainboards had what's called a north bridge and a south bridge chip. And that assisted the mainboard in moving data from the CPU to the memory and back. This particular mainboard has a combination chip. So north bridge and south bridge. The heatsink right here is covering that chip. But that acts as sort of the middleman between the CPU and memory when it's being addressed. And you would have other components on your PC. You would have interrupt controllers, and you would have other